It's time to talk about three functions that have a lot of people that are newer to JavaScript development scratching their heads. Call, apply, and bind. These three functions have to do with something we've already talked about. In our execution context, we have our variable environment, our outer environment reference, and we have this thing, this variable that's set up for us called this. We've already seen that the this keyword can point to the global object in some cases, and in other cases it can point to the object that contains the function, if the function is a method attached to an object. Wouldn't it be nice to be able to control what the this variable ends up being when the execution context is created? Well, JavaScript has a way to do just that. And that's where call, apply, and bind come in. We could have talked about this before when we talked about objects, functions, and the this variable. But to properly and fully understand call, apply, and bind, especially when looking at it syntactically, we needed to have a complete understanding of first-class functions. So, we already know a function is a special kind of object. It has a hidden optional name property, which can be anonymous then, if you don't have a name. We have a code property that contains the code, and that code property is invocable, so we can run the code. All functions in JavaScript also get access to some special functions, some special methods on their own. Remember, a function is just an object, so it can have properties and methods. So, all functions have access to a call method, an apply method, and a bind method. And all three of these have to do with the this variable and the arguments you pass to the function as well. All right, let's take a look. Let's suppose I have an object, a person object. I'm going to use object literal syntax. I'll give a first name John as a property, a last name Doe as a property. And let's do a method called getFullName. And inside my object literal, I'll use a function expression and set up this function. Let's say I use this.firstName, this.lastName, and then I'll return full name. All right, so I have this object with these two properties and this method. And the method uses the this keyword. And remember, since this is a method on an object, when this function is executed, the this keyword will point to this whole object, the person object, the object that contains the method. All right, so what about call, apply, and bind? Well, let's imagine that I have some log name function that exists outside of this object. And maybe it takes a couple parameters about language and some other things. And I'm just going to go ahead and console.log. I'm going to say logged, and I'm going to say this.getFullName. All right. So for starters, we know that this will fail right here. Why? Because the this keyword here at this level is going to be pointing to the global object. I'm not a method. This function isn't a method of the person object. So when I go to run this, actually let me execute it, sorry. Let me go now run this. It says undefined is not a function. The this is the global object and there is no getFullName, so that's undefined, and then I try to invoke undefined and it gave me an error. Well, that makes sense. But wouldn't it be nice if I could control what the this keyword points to? So let's make a new function called logPersonName. And I'll use the logname function, and all functions in JavaScript get access to these three methods. The first we'll use is .bind. Notice I'm not invoking the function and saying .bind because the function returns a value. I'm looking to actually use the function as an object and call a method of that object. So just log name dot bind, because this is a function object. Dot bind. All function objects get this. And then I can pass to it whatever object I want to be the this variable when the function runs. The bind function, the bind method, returns a new function. So it actually makes a copy of this log name function and sets up this new function object, this new copy, so that whenever it's run, when its execution context is created, the JavaScript engine sees that this was created with this bind, which sets up some hidden things in the background so that when the JavaScript engine decides what is the this variable, it says, well, it must be that, right there, whatever was passed to the bind method. So I'm affecting the JavaScript engine as far as what it decides when it creates the execution context for this new copy of this function. So if I call log person name instead of just log name, I call this new copy of the function created with bind. When it says this will be the person, this person object. So I can call the get full name, and it logs it. See that? I could even have done this here. I could have created the function on the fly and then said .bind person. And then if I called just log name, instead of erroring, this now points to a copy of this function that was created on the fly, bound with the this variable to whatever I want the this variable to be. So this becomes essentially right here person.getName, because I passed it in to the bind. That works too. So the .bind creates a copy of whatever function you're calling it on, and then whatever method you pass to it, whatever object you pass to this method, person object passed to bind. The person object is what the this variable points to by reference. Make sense? So let's say that I want to also log, let's do it below here, log my arguments, just so we see this as well, everything that's happening. And then, since I'm going to call this a few times, I'll go ahead and set up just a line or something so you can see every time this is called the difference. All right, so I called this. Notice I have two undefined arguments. My language 1 and language 2 are undefined. But I can pass an argument. Remember, this is a copy of the function, so it still takes the same arguments, only the this variable will be person. So that still works, and I see English and undefined. I'll even just put a space in here just so we can see it clearly. How about that? There. All right, so this is what bind does. Creates a copy, and I can tell it what the this variable is, at least in part. Let's move on first to call and apply before we show any more. If I do logname.call, this calls the function. It invokes it. I could have also called the function like that, with parentheses. Move down a bit. But instead I did .call instead of parentheses, because .call also lets me decide what the this variable will be. The first thing I pass to call is what the this keyword should point to. It works the same as these parentheses, but lets me control what this means. And I can also pass it parameters. Unlike bind, which creates a copy of the function, call actually executes it and then just decides what the this variable should be, and the rest is just the parameters that I would normally pass to the function. See that? So if I call this again, there's my dot call. It executed the function. This bind did not execute the function. It created a copy with the this variable set up. This one actually executed it, and I just passed the parameters as well. Logname.apply. All functions can get .apply. This does the exact same thing, only one difference. If I tried to pass variables like that, I get an error. Arguments list has the wrong type, because the apply method wants an array of parameters rather than just the normal list. And that's the only difference between call and apply. And that works too. An array can be more useful, especially under mathematical circumstances. Let's say I was adding a bunch of numbers, and it could be any number of variables or other things like that. So I just have two options depending on how I'm coding, what my pattern is for how I'm using this function. Make sense? And again, I could do this on the fly. I could take this function, trick the syntax parser into realizing it's not a normal function statement, it's a function expression. But rather than immediately invoking it with these parentheses, I'll immediately invoke it using, let's say, .apply or .call. And I'll say person and give it an array of whatever I'm passing to it. See that? Looks a little odd, but I'm just creating a function on the fly and then invoking it using .apply, because all function objects get access to this method, telling it what this is and passing some arguments. So that should work again, and it does. Yet another list there. Just so you can see the difference, I'll swap these two. There it is. So that's interesting. And I know what you're probably thinking. When would I ever actually use this in real life? Well, let's talk about two instances. So I've scrolled down a bit in my code, and the first thing I'm going to show is something called function borrowing. Let's say I have a second person object with similar property names, but different data. Let's say Jane, last name Doe. Now this is very similar to my first person object, only the second one doesn't have a getFullName method. So I'm going to do something called function borrowing by using call or apply. I'll take that first person object I created, which does have the getFullName method, and since it's a function, it has access to .call and .apply. I'll just use .apply. So it's going to execute, invoke this function, and I'm going to tell it, but the this keyword should point to my person2 object. See that? So I'm invoking this method here on this object, but since it uses the this keyword to access its other properties, I'm setting the this keyword to my person2 object. So if I console.log the results of this, Jane Doe. There it is. See that? So what I've done is I've borrowed a function. This method here, this function on this person object, I wanted to use it for my person2 object, so I borrowed it using the apply. I could have done the same thing with call. Make sense? So you can grab methods from other objects and use them as long as you have similar property names so that the function works. Let's look at a second example called function currying. This in particular has to do with the bind the dot bind, because that's creating a copy of the function, and it actually does something rather interesting if you pass parameters to the bind. With call and apply, passing parameters just passes the parameters. But with bind, you're creating a new copy of the function. So what happens if you pass parameters to it? Well, I'll say I'm going to create a new function called multiply. And that's just going to return a times b. I'll pass it two things, two numbers, and it will multiply them. Then I'm going to create a new function, a copy of the multiply using dot bind. I don't care about what the this keyword is in this case. I'm not using the this keyword. But I am going to give it a parameter value. Now remember, bind is not calling. It's not executing the function. So what does this do? Since I'm not executing it, what does giving it parameters do? Giving it parameters sets the permanent values of these parameters when the copy is made. So by setting 2, what I'm saying is the first parameter, because the first thing I put is the value of this keyword and then my parameters, the first parameter will always be a 2 in this copy of the function. The variable a will always be a 2. This is essentially equivalent to taking this function and then setting up what this keyword will be, and then instead of having a, I just permanently set a to 2. See that? That's what this is doing right here. So the bind is permanently setting this right there, and I can call my new function, my new copy, and if I pass to it, let's say a 3 or a 4, this will end up as the second parameter, the b. So if I console.log, inside the console.log, so what I've done is I've said, give me a copy of this function where this variable is set up, and I've also decided to set a permanent value for this first parameter. When you call this new copy, I've essentially done away with this first parameter, and so whatever you pass will be that second parameter. So if I run this, 8, 4, which is b, times 2, which is the permanent a. If I had passed both parameters to bind, I'm essentially telling it this is the value of a and b always, and this 4 just becomes an extra parameter passed to the function. So even if I pass 4, it's going to be 2 and 2, so I'll always see result of 4. If I made a 5, it's still 2 and 2. 2 times 2 is 4. If I pass no parameters, then I have a and b open, so I could do 5 and 2, and that would be 10. But in this case, I've intentionally made a permanent version, a permanent copy with certain parameters by default. I've taken my multiply and I've made a multiply by 2. Then I could take this multiply function and make another multiply by 3. Set a to 3 and then call that. And I get 8 and 12. See that? I took a function and created a new function from it with some default parameters. That's called currying. Big word alert. Function currying. Creating a copy of a function but with some preset parameters. This turns out to be really useful in mathematical situations. So if you're building a library that has to do a lot of mathematical calculations, you can have some fundamental functions that you can then build on with some other default parameters. A really good, useful usage for bind. So that's it. That's call, apply, and bind. Apply and call invoke the function and let you set up the this keyword, and then pass the other parameters if you want in two different ways. And bind creates a copy of the function, lets you set up what the this keyword should mean, and also lets you set default parameters, permanent preset parameters if you want. So these are all useful, and you'll see them. Don't be scared by them. They're just methods on the function object that have to do with setting up the this keyword and how and what happens when the function is invoked. All right, let's move on.